Hello guys, this is Chittur and in this project we are going to look into finding the optimum number of clusters of iris dataset and representing it visually. In the first step we are going to import the necessary libraries to do this project. They are NumPy, matplotlib.pyplot, pandas and datasets. After this, I am going to load the data from datasets, that is the iris data, and store it in iris variable. After that, I am going to convert iris into pandas data frame and store it in iris df. Having loaded the data, let us see the shape and contents of our dataset. So, doing iris df dot shape, there are 150 rows and 4 columns in our dataset, and the contents are sepal length, sepal width, petal width in 4 columns of our dataset. So let us see how we can find the optimum number of clusters. I am first retrieving data from the pandas data frame iris df and storing it in data. Now I am importing KMeans from scikit-learn.cluster, and then we are going to model 11 times in this loop. So what we are doing is we are giving different values of cluster we want and seeing how much inertia we will get. The model with the least inertia is the best fit for our need. So these are the different things. KMeans ++, it will choose the cluster centers in a smart way to speed up convergence, and these are the different things you need to look into before giving values to this modeling of our model. And each time we are fitting the model to the data and seeing how much inertia it contains. So as I said, a good model is the one with lowest inertia and lowest number of clusters. So we have run the loop for 11 times. So let us see what is the output from each of them, that is the inertia of each of them that we have stored in WCSS. So I have plotted it. So we are going to use elbow method. So elbow method is to find the optimum number of clusters. So we have to select K at the elbow. So in the figure we see that after 3 the line is almost linear. So we have to select that value. The optimum clusters is where elbow occurs. This is when the within cluster sum of squares doesn't decrease significantly with each iteration. So we can intuitively say it occurs at 3 from the figure, and now we are going to use cluster size as 3 and model now. After doing that, we are going to use that built model to predict on our data. So I have stored it in KMeans. Having completed, let us see visually how the model has clustered the data in our dataset. So I have plotted the data and given legend and shown to the output. So the final output looks like this. So the data output contains iris setosa, iris versicolor, iris virginica, and these yellow things represent centroids of each cluster.